Hey, welcome back. In this video, I want to show you a little bit more about auto-scaling capabilities within my Kubernetes cluster. So again, as before, I've set up my Kubernetes environment that we will deploy our items to. We have one still running on my third node, so it will have the name worker03 as before, and I want to auto-scale this environment based on auto-scaling the Kubernetes cluster. Right, so if I go into and use the kube control magic command, so we can still look at the pods, output wide, you should see that one. So this is my atom deployment I was just talking about. It's running now for 44 minutes on this IP address within the cluster, and this is my node. So, reflecting in the name of the actual atom here. So having said that, we still have our service. So if I go get services, we still have our Atom service listening on our external IP address, which is the IP address of the master node, listening on this port 9090. So still we should be able to access the service using our curl command and then getting back our information, patient data information that the web service is serving. So having said that, what we want to do is auto-scale the complete environment. So for that, again, kube control, we have something called horizontal pod autoscaler. So we haven't configured it yet. So if I do a get HPA, we should get back no resources found, which is all good. For it to work or start working, I should issue a command, which is this one. So again, kube control, but then the command will be autoscale. We have to tell it what deployment to autoscale, and also a threshold or a metric that we're going to look after. So, I mean, the CPU percentage is basically around utilization of my CPU, right? So once it reaches the threshold of 25%, we'll go over it, then we will start autoscaling. And we have set boundaries on the auto-scaling. So I'll have a minimum of 1 pod and a maximum of 4. Okay, so let me issue this. Now it's been auto-scaled, so that's all good. And if I now go back to the get HPA, we should see the actual horizontal pod autoscaler, having this name referring to this atom deployment. And then the threshold that I've set with the actual value of it, which will be reported within a minute, right? It's collecting the information basically of all the various pods on the various nodes. We set to have 1 minimum pod and a maximum of 4 number of pods here. And currently we have 0 replicas, and we just started this. Okay, let's see if we already have a value here. There we go. So the actual CPU utilization is now at 2%, which is, well below the 25%, so nothing will happen, no auto scaling. So we will stick with the actual 1 pod, 1 atom from a platform perspective. Now let me spike up that CPU performance by just starting what I have here, JMeter, which is a nice tool, Java thing, and it will be starting now. And this tool for me will simulate a bunch of users actually, right? So I can define some load. In this case, I call it HTTP request, and you define a thread group. So we are simulating 25 users now, each of them concurrently accessing this simple web service, more or less. Right, so this is my actual HTTP request here. As you can see, we're using HTTP, we're using the external IP address that I've told you about, listening on this port 9090, and doing a get for the path that we've seen before. So let me just start this one. So while this is ramping up, we should be able to see it starting. There it goes. So it's starting, it's doing all of the calculations. And let me go back here to see what's happening. So my pod will still be, single, will be alone until the information gets collected about the CPU performance and will reach the threshold, which again, as I said, I think it's set by default on a minute. So if we are a little patient, we should see it spike up here, looking at the targets, and we should then also see the extra pods being started. So let's be patient here. And the extra pods being started should eventually also reflect here back in the platform, where we should see extra atom deployments within my environment, obviously. So let's see what happens. There we go. So we went from 3% by all that concurrent requesting to 361%, which is way above the 25%. So let's see what that means for my pods. So if I look here, here we go. So 22 seconds ago, we've started 3 extra pods or deployed them on 3 nodes, actually nicely distributed onto the, the extra workers that we have within the cluster, having a new atom deployment name and so on and so on. But these will be ready at some point for taking the work as well. And then the targets here, the extra CPU utilization should go down because we will be using 4 nodes now for my my serving. So let's see. This will take again a minute before it reports back in the new value. There we go. So it's now down to 37%. So that's the new value, while the extra nodes are starting up. And let's wait for the platform to report back in here as well. So we still see only this one. And let me see if minute should be somewhat of what is needed before the items actually, are ready to serve back information. So let's wait and see here before that actually gets reflected within the platform. The other thing we can look into later on is the process reporting, right? So let's quickly go back here. There we go. So my 4th node is already started. 2nd node is ready there. We stopped the test already. So we've spiked it up enough to scale the autoscale the Kubernetes cluster to 4 nodes. But let's start it again. So let's see what the HPA is doing here. It's at 55% here. Let's go back here and do an extra run. So it's running now. As you can see, we auto-scaled it to 4 workers, nicely over the 4 nodes that we have. And let's see if it's starting again. Yes, it is. So if I go over here now, having a cluster with 4 nodes, all the service is calling the external IP. So if I go to process reporting, as you can see now here, we have, the work nicely distributed over the various nodes. So we see multiple atoms working here in parallel. We have loads of requests coming in, obviously, from the 25 simulated users, but that all looks great and nice. So this is auto-scaling. Let's go back here. So let me close this and go back. What we should see once the test is over, and we can, again, it's very high, even with the 4 replicas. Let me show you the pods themselves. They're still running here. Let me now go into JMeter, and if the test is still running, let me stop the test here. So we stopped the test, and the number of requests should actually die out. So I should go here. And over time, but again, this will take a little bit of time before this settles into a normal number, and then we should see the auto scaling also doing the scaling down for me. Right? Remember that we have set minimum pods equal to 1, so if they're not needed anymore, based on the actual CPU utilization, we will scale down back to 1 pod or whatever is needed. Currently having 4 pods here running in parallel. So let us just wait. It's dropping already, which is all good. It probably will take another minute, so you have to bear with me here. Let's see what that means for the actual pods. Obviously, they should actually still be running because the load is still reported as high. So as I've said, that will take some time here. Continue on reporting back in the actual CPU utilization until the actual nodes will die. We will be stuck with only one node that might be or will probably be the single node that we had before the autoscaling started. So let's see. There we go. So we're back at 2%, right? So we killed all of the requests by JMeter. I killed all of those. And now the cluster should see, and probably it will, wait for some time to see whether it will actually stay at 2%. So we won't be switching back and forth between 1 and 4 nodes. But in the end, if I go to pods, they're still running. So it might take another minute, in fact. But let's just wait for a while to see what is happening there. So I'm still getting my pods reported. It's running. Percent. HPA, yeah, that should stick at 2%, not issuing any request anymore to the cluster. Service. There we go. Nice and smooth. So again, this sticks well below the 25%. So the cluster decides now to go back to the minimum pods set to 1, and you can see 3 of them being terminated, and you can see it reflected here within the platform as well, right? So 3 of the atoms will be dying out here, and in the end we will be stuck with the only 1 atom here. So let me see. There we go. It's actually back to 1%, but my pod should be reporting now as running, and there we go. We're back to the single pod worker 03. So this shows you a little bit about autoscaling that you can do with the Kubernetes cluster relating to Boomi and the atom deployments, the Docker containers in the pods that we deployed, and really cool as I showed you. Thanks.